What's going on YouTube? John and Tony at our local airport with the Freewing F5 80mm. I'm gonna go ahead and just say it now. This is not stock, not even remotely stock. I've got upgraded Stabilator servos. I use the AGF RC ones that pull 3.8 kilograms per whatever the unit of measure is, but they're really strong and they throw really far. The wing servos and the flaps are identical. I haven't changed those. I did put the F16 80mm E-Flight motor in, which is an FMS motor, and the 100 amp Avian ESC. I'm also running this with the KMRC Model.com Afterburner unit. It's a pretty cheap little burner. I think it's like maximum of 40 bucks. I may have to dub over myself to correct this, so we'll see how that goes. But it was really easy to set up. All I had to do was loop the little unit in there and set the program to when I wanted it to come on, which was 50% thrust, and then you just send it. So we are in an interesting day of flying here. There's a lot of wind, but for now, for some reason, it's decided to stop. This is the pure uncut Maiden flight. I'm hoping beyond hope that this thing's gonna survive. It wasn't the most expensive model in the world, but it looks cool, and I've always wanted an F5. So we're gonna start with takeoff flaps. Oh, and check out the throws. Pretty crazy. Let's go ahead and do one more pre-flight check here to make sure everything's working the way it should. Left, that look good to you, sir? Yep. Right, looking good. Up, down, right, left. We're gonna throw it in safe. Just double check that the corrections or the directions are being corrected the right way. As we tilt the wing to the right, that aileron comes down to push the wing back up. As we pull it up to the right, the aileron pops up to push it down. As we flip it upside down, it frantically tries to make itself get pushed in the right direction. Now the wind has shifted, now it's coming from behind us. We have to take off that way. Anyway, the elevators are correcting in the right direction, and looks like we're good to go. So I guess we can go ahead and just taxi her out. We are actually flying this with a Spectrum 5050C pack in here with a little burner unit attached to it and a remote receiver up front. It took me a bit of troubleshooting to figure out exactly where I needed to place the receiver antennas to make sure that I didn't lose signal. Remote receivers are totally worth it, guys. There's really no reason why you shouldn't have one. All right, here we go. Sending it. Look at that burner.
Flaps up, gear up. Stabilators 8 down.
Wow, that's a little touchy. We're gonna throttle back. Let's see what the roll rate is with these stabs.
1 minute.
Okay, so maybe I should turn them off.
Ailerons.
There we go. A little less touchy now.
23.69 volts.
Is that gear out?
Got a right main down.
Gear down. Gear up.
Interesting. She's flying a little weird.
Still down.
I know. I got to turn it around to get it set up the way I want it to. I think it's the BEC not pushing enough power.
Gear down.
Are the gear even coming out?
Gear up.
See a nose gear.
Gear down.
Oh.
Gear up. 23.62 volts.
We'll just deal, I guess. If I have to land it in the grass, I'll land it in the grass. I can just paint over anything that gets messed up. Let's see what the speed is.
54.1 miles per hour. 23.89 volts.
Gear is still stuck out. I'm surprised that it's stuck. It was working just fine.
Gear up. Gear down.
It sounds amazing though.
52.8 miles per hour. 23.04 volts.
See what the vertical performance is?
Stabilators 2 down.
Wow. That's got some serious vertical.
Gear up.
And that was with the gear down and my rates for that.
Gear down. Gear up.
I can't get the gear to come up or down for the life of me. This is going to be a short Maiden for sure. I think it's going to wreck the plane on landing. That's unfortunate.
22.84 volts.
Now let's put it into a quick. It looks like the gear went up. Let's see how fast you can actually go. No, it didn't. Max speed?
101.3 miles per hour.
So 101. I bet we could have got it faster if I could have gotten the gear to go up. That's really unfortunate. It might actually end up being fine if I can get her down safe. Let's test the flaps out, make sure they work.
22.5 volts. Full flaps.
Yeah, it looks like it flies just fine with the flaps.
Flaps up. Gear up.
Trying to check the gear. This is really, really obnoxious that this happened. Whoa. And this wing, that's really unstable feeling up there.
Gear down. Gear up. Gear down. Gear up. Gear down.
I am at a
3
loss for
minutes.
words why the gear isn't coming up. That has never happened to me. No matter what I do to it, it won't come back up. Let's try letting the power off for a few.
Gear up. Gear down. Gear up. Gear down.
You gotta be kidding me, man. Well, so much for that, huh? You wanna try grabbing it out of the air if I make it high alpha?
22.43.
That might work. Let me see if I can get it to high alpha and see what it'll do. Because if I can get it to slow down before it smacks into the ground, we might actually be able to save it.
Alpha.
I think we might have this.
Wing normal.
Sure is pretty, man.
Pack 21.3 volts. Gear up.
Want to try Cobra first too, since we're only going to wreck it anyway?
22.34 volts.
Some rudder to turn her around.
Flight pack 21.45 volts.
Well, actually doesn't Cobra well at all, does it? Maybe it wasn't fast enough.
4 minutes.
All right. Well, this is really, really, really awful. Make sure there's no mixes going on before we land her. I don't see anything on my screen.
21.57 volts.
Let's try this.
Flight pack 20.7 volts.
Just about lost her. It's not a jet you want a Cobra, that's for sure. Hope you caught all that.
I did. You could always try flat spinning it into the ground.
That'll just destroy it. We're going to turn it around and come into this wind. I can hold it with a little bit of alpha.
Stabilizer full.
I'm going to turn my gains up too. I'm just going to walk out here and see what I can do. Yeah, for sure.
Full flaps.
It is.
Flaps up.
I broke the nose, but I think otherwise the jet's okay. Let's get a look at what happened here.
22.6.
Yeah, she looks no worse for wear, man. And the nose, it's a clean break. I can just re-glue it. So I think we're actually in good shape. That doesn't bode well though. I'm not really happy with that at all. In fact, that's really almost infuriating. I'm trying not to get angry about it, but it's like, how does that even happen, you know? Now that we have no load on the motor, let's get some diagnostics going here and see what actually happened.
Gear down. Gear up. Gear down.
So the gear came up, so we know that worked. But the question now looms is how did the gear not actually go back down? You know, I wanted to do some touch and go tests, but I'm not going to complain too much. There's a lot of wind. Let's turn the plane into the wind like this. I'm not going to complain too much because I got it back in one piece. I mean, there's literally no damage to it aside from this nose cone piece, pitot tube in the front, which was really only held on with a little bit of glue anyway, so it's not really a big deal. We're going to come back, maybe do some tests, maybe get it back up in the air, but if that's the end for today, we got some tests out of the way and saw that it can haul some butt. We'll fly it again in a bit. See you around, guys. Okay, so we figured out what the culprit was. It is, we got the magic smoke from the wire. I think all 3 retracts burnt out yet again. I had them burn out before because I connected something the wrong way. And now they burnt out this time because these 2 wires, the positive and negative, touched. So that was why the gear wouldn't come up and down. I had thoroughly tested it. Everything was working fine until we took off. So it wasn't like this came out of the blue. It wasn't like there was some negligence or something. It's almost like it just said sayonara and it was done. Sometimes this stuff happens, guys. I'm just very happy we figured out what the problem was, and I'm also happy that the jet survived. So after repairing the nose pitot tube, I think we'll be good to go. But in the meantime, we'll have more on this jet later. There's a lot of work I need to do to this thing. It's super unstable in the sky, but we'll get it back. What's going on YouTube? Day 2. We are back a few days later. Miraculously, after the electrical wire for the 3-way cable burned up on these gear, the gear still work. I was totally getting ready to order some new ones, and we're good to go. I cannot believe how lucky we got with that. All right, we're gonna try number 2. I make it a little nose heavier this time, although I don't think it was really the issue. I think if I had to wager a guess, what the real issue was is that the jet wasn't stabilized. So I went ahead and increased the gains on all axes, and we'll see what we can get out of it. This is my first time flying for today. There's our full throws. Get the flaps out. We're gonna have to do some testing to make sure everything works correctly. Turn the voice up, turn the screen on so you guys can see the speed callouts, or hopefully you can see what's going on with them. Just make sure the GPS is working. It is. We're good to go. Afterburner running? Yep. Here we go. Oh, this is again the Afterburner from KM Model or KMModelRC.com, or I'll put it in the link so you guys will be able to see it. Don't worry.
Flaps gear up.
Oh yeah, all the gear are working. Let's get a speed test on this bugger. Just feel much more stable too.
Stabilator 6 up.
This is the FMS 2100 Pro motor. Feels so much better now. Oh my God, maybe not having that third retract stuck out helped.
84.5 miles per hour.
All right, let's get a level speed pass. This is a 5050C Smart Pack, the same one we used on the day of the event, as we'll call it. Speed?
115.6 miles per hour.
Ooh, a little bit of a stall coming out of the top there. 115 on a level pass. That's not half bad. I was expecting more, but we'll see what we can get with a dive now. We're gonna not do too much. I want to practice landings with it because we didn't get to.
Flight pack 21.4, 115.6 miles per
115,
hour.
so I don't think we're gonna get the much vaunted 165 I heard about. That's okay. Let's go ahead and get off the taxiway here and get ready to do some approaches. I'm gonna stay in the thrust as we turn. It seems like this jet's gonna really need it. This thing looks like a stall machine, as in not stall as in short takeoff and landing, stall as in like you're gonna drop a wing like so easily.
Gear down.
Gear are out. Can you see the gear? I'll abort if, on the approach if they're messed up.
Full flaps.
Yeah, you got 3 down.
3 down? Yeah. You can see better than I can up there. Keeping the thrust in.
2 minutes. Flaps up. Gear up.
Okay, got a practice approach. That was halfway decent, man. It's not as fast coming in as I thought it was gonna be. Oh, my heart is racing right now. Not quite symmetrical rolls, a little bit asymmetrical, but that's kind of how fighter jets are sometimes. It's really hard to get one that's not, or like purely symmetrical. We're gonna hold off on the full flaps here momentarily. As soon as we level the wings out, we'll drop them, because as you pull the elevator, you come close to risking hitting the wing's critical angle of attack. We want to avoid doing that. I'm having to push the stick down. I gave it nose up. Man, that thing hauls ass when it lands. But we got it down in one piece. That is a successful, true maiden flight, or re-maiden, as we'll call it. Turn around, baby. Don't you make me come get you. You're gonna turn. Okay, I gotta go get it. It made me go get it. It told me who's boss. We'll be right back. So we're halfway through our walk of victory. I'm not calling this a walk of shame by any stretch. I'm just happy this thing came down and survived. I was afraid that I was gonna suck up the gear into the gear leads into the motor again, like I did last time. What ended up happening after further inspection, I pulled the entire thing out, and the actual Y cable, the damn thing got severed, and then it shorted out. So if we go ahead and test this out right now, interesting grip angle on this thing. Everything works just fine. So it's a beautiful little model. I think I might actually end up min-waxing it now that it's survived its maiden flight. Hopefully it'll survive the rest of today. We got to do some more speed testing with it. And then we also have to do some agility testing and see what this thing can really do. So that'll be part of the review for this jet. We'll go through and really beat it up so that you guys don't have to. All right, we're taking her right back up after that successful maiden. The afterburner's kind of stuck on. I need to reprogram it. Sometimes it gets a little wonky. Here we go.
Flaps up.
I moved the battery a little further forward. Man, she like really snapped in those rolls, didn't she? All right, so we're back. We just had to quickly shut off. Sometimes flying at this time of year screws things up a little bit. Plus, standing in the shade never helps. It's a very agile little jet. Let's get the callouts going.
23.51 volts.
Plenty of power left. We'll do some more speed testing, maybe on the 4,000 packs. I think we can get maybe better performance out of those instead of the 5,000 we're using right now. Let's get her up and see if we can get her to finally flat spin.
5 minutes.
Basically backflips over itself. No, it will not flat spin, even with the stabs. It's a very strange little jet. It's got a very interesting profile to the way it flies.
22.32 volts.
Let's see if we can get a knife edge test going. Hopefully it doesn't rip the rudder off. Get her down nice and low. Just do a low pass with some speed to it. Get her up high. And then we'll flip around, do a knife edge pass, see if we can get her to stay in it. Going in with the rudder now. Pulled out of that. It started kind of pointing to us, which is interesting.
22.32 volts.
It does some pretty good agile sliding, which I kind of like. Let's do the inverted gear test.
Gear down.
At least the gear coming out and working. Oh, we didn't do inverted alpha testing. Let's do that too, while we're here, getting all this stuff tested and knocked out. So far, as far as review thoughts go, this is a pretty interesting little jet, man. It definitely requires speed to fly.
6
Just did an inverted Cobra. Going to get out of that. I didn't realize it would do that as well as it did.
22.32 volts.
Okay, how much power we got?
22.09 volts.
Still enough power to mess with. Let's get a low, high speed pass.
Flight pack 21.23 volts.
Okay, we hope that wasn't the landing gear. If it was, I'm gonna be so annoyed.
Gear down.
No.
Gear up.
Okay, so it just powered down. It kind of exceeded its tolerances. So let's go ahead and clear the runway, bringing her in. I'm gonna walk up a little further
22.34 volts.
so I can make the landing work better.
Gear down.
There we go.
Full flaps.
Flaps coming in fully. Hopefully I don't have to push, yeah, I gotta push the nose down. I need to adjust that mix for the flap system.
Flight pack 21, flaps up.
Okay, we're gonna turn around and land. She kind of came right at me like a missile.
21.79
I'm sure you
volts.
caught that.
7 minutes.
When in doubt, throttle out. Gonna go half flaps because the
Flaps
CG
50.
change is definitely messing with stuff. Some jets get like this, guys, when they have narrow wings like this and they're already kind of squirrely feeling, adding flaps when the CG is changed can really screw stuff up.
Full flaps.
Golly, that thing's just hauling butt. Incredible that that thing flies at all. My review so far is this is not a beginner's level jet. If anybody tries to tell you that this is, kindly point them to our first video example and how squirrely it was in the air without a gyro. If you fly this thing without a gyro, I don't know how you're supposed to get it back safely. You need that computer assistance. It's funny because this is an older jet from like the 50s, right? It's definitely an older style jet, 50s and 60s era. You can just tell by the shape of the snoot and how long it is and everything. It's got kind of like that classic F-104 kind of style to it. And it's just such a handful to fly, but it looks cool and it's fast. Not as fast as I was hoping it would be, but it's still pretty cool. So my initial impressions are this is not a beginner's level jet. It's not even an intermediate level jet. This is totally an advanced level jet. And this thing will kick your ass if you're not expecting it. We'll keep testing it some more in a bit with a lighter weight battery and definitely gonna go heavier on the nose for sure. So here we are. We're back with the F5. I just realized I've been landing this jet pretty much with full span flaps almost exclusively, which is interesting because it doesn't slow it down at all. But then again, it's kind of drooped ailerons, not quite full span, where they're not as far down as the flaps are. That's where they were before. So, and this is with full flaps. I loathe this, to even test this out because this thing's just so fast. I guarantee it's going to drop a wing if I do it. Either way, hidey-ho and have fun and all that. I think we got one more battery after this, so we're going to just go tear it up on this 4050C. Let's do it. Oh, I fixed the afterburner too. There we go.
Flaps up, gear up.
Much better. Let's get some high-speed passes right in front of us. This thing does feel kind of locked in now. I kind of like it.
3.12 volts.
It is a little rocket for sure.
.8 miles per hour.
Still hitting 116 as our top speed. Let's go up and get some high altitude.
21.41 volts. Flight pack 21.16 volts. 123.7 miles per
123. Cool. Still not hitting that 165 I heard about with the FMS motor. This comes out of the 80mm F16. I'm just glad I got this thing to fly at all. I call that an accomplishment for sure. It sounds incredible. A lot of down trim I keep forgetting to add because I'm just having so much fun zooming. Let's level her out. Whoa, there was a little bit of a ESC cut out there for a second.
Stabilator's 12 up.
Okay, I think we're good.
22.79 volts.
How's the focusing going on, bud?
It's all right.
Cool. Let's get you a better view. Get her a little closer to us this time without stalling her out into the ground.
Flight pack 21.27 volts.
See if she'll flat spin now. There goes the canopy.
22.91
No,
volts.
don't worry about it. We'll find it in a little bit. It can't be hard to find.
Gear down.
That's another issue with this jet. The canopy is a little weird coming in. This thing's a rocket, so Tony knows to step out of the way because we don't want to hit anybody with this thing. Flaps coming in. There we go. Now it's not in full span. It feels much more behaved. Gosh, it was so weird earlier.
22.93 volts. Flaps up.
Take it. Arrested carrier landing. I didn't want to flip it. At least you guys get to see how good the retracts are and how they hold up to the grass. So those of you guys who want to know, does it fly off of grass? The answer is probably. But how well does it hold up to the grass? The retracts are fine. They didn't come out at all. Of course, I had to glue them in manually myself. Man, this thing just ate up the grass, didn't it? Let's go ahead and cut here and go find that canopy real quick. So we're back with the F5 from Freewing, 80mm, using the FMS motor upgrade from the, what is it, the E-Flight F16 80mm. Here's the KM model afterburner unit. This is pretty simple to work with. I'm going to caution you now, you may want to put a couple dabs of like CA glue on these contacts to keep them from coming loose. It can happen. It did happen earlier. I had to go back into my pictures to double check and make sure. I mean, for the price point though, those kind of things are to be expected. It's not really a big deal. I mean, if you just have to add a couple dabs of glue for the amount of money you're saving on the unit itself and how bright it is, honestly, it is actually pretty dang bright. I'd say it's a really good unit. Just has some things like, you know, with you get what you pay for and all that. Being on the cheaper end of things and being more affordable for more people means there has to be some compromise somewhere. So just be aware of those kind of things before you fly. Get all this grass out of here from our last grass landing. As you guys can see, there's literally no damage to it. It went through the grass. It didn't even scrape anything. Actually, no, there is a small scrape here, but it's whatever. I can just fill that with foam putty and it will look exactly the same because I already did that here from the grass landing on the Maiden, and you can barely even tell it. I had to actually point that out to you for you to see it. We're gonna go this way, actually. I don't like taking off the other direction. Check out that blood spatter there from one of the mosquitoes I hit with the leading edge of the wing. All right.
Flaps 50.
All right, so we got half flaps in.
Flaps 50.
I feel like we could probably go even more on the full landing flaps, but we're just gonna go with what we got for right now. Got the Afterburner from KMRC, and let's get her going.
Flaps gear
One of the better takeoffs. I just wish she would have tracked straight and true the whole way. 4,050 C pack, as you guys saw.
Ailerons.
Just leave the ailerons on for now. We don't need the Tailerons. Kind of like how it flies without them. It's less touchy. Although for landing, I think I turn them on.
Tailerons.
Let's get her in for some lower level flying. Full flaps.
Flaps up.
A nice backdrop with the trees. I love this airport. It's got such a beautiful arrangement of trees here. The pines especially. Pine trees are my favorite tree. Anybody who knows me will tell you that. Longleaf pines especially. I just wish we had them here in North Carolina. We appear to have logged them out of existence a long time ago. A ton of them in Florida though. I think we're gonna save the agility testing for another video. Gotta be careful pulling it too much. Those wings will stall.
1 minute.
It's got a beautiful profile to it in the sky. I love the red and white. It's so easy to see, but the wings are very tiny. So you're flying a decent amount of mass on a very highly loaded wing. Pulling full back, there's your stall. That's what it looks like when it stalls with full aggressive throws. It departs laterally, like it loses all vertical stabilizer authority.
22.57
So let's go show you guys some more stall testing while we're still flying this plane and got plenty of power to work with. Again, I don't believe that a review of an airplane can be called a review if all you do is fly in a circle. You guys need to see how these things fly, what they do, what to expect from them. Even if I crash, you guys need to see this stuff. I'm gonna hold full up elevator upside down. It's actually much more stable upside down. It didn't even stall as violently as it did. Let's get her going again.
22.72 volts.
There, it actually started stalling there. It just kind of departed again. So the wings are just so highly loaded on this plane. For those of you guys who don't know what wing loading is, it's how much weight the wings are carrying in the sky. That's the very simple aerodynamic explanation for it. I'm not an aerodynamicist at all, but I understand that much at least. And generally speaking with these models, you want to have something that's less highly loaded. The less loading you have, the floatier the plane's going to be. Generally speaking, the better it will fly. It's one of the reasons why really good models, like really good 3D balsa models, tend to have very little wing loading, so they can float through the air and do crazy, amazing stuff that if you were to pull the elevator too hard on them on a higher or more highly loaded wing, you would end up stalling the plane out and crashing it easily, as this happens right here. See how it departs? I can save it though, I'm high enough, but if I was too low to the ground, it would nosedive. Let's get a knife edge test going, see if it can handle that this time.
22.41.
Unfortunately, I don't know the ESC temperature right now because I don't have the avian telemetry anymore. I gave up the avian telemetry to have the Afterburner, which I thought was worth doing. It would be nice to know how hot it was getting. Coming in with, I want to go up a little higher and give it full rudder because I only gave it half rudder and it was getting a little weird. So let's do it to the right. Full rudder.
Flight pack 21.61.
It handles it pretty well.
21.57 volts.
Okay, we're gonna go ahead and clear the taxiway, get ready to land. We're gonna go land right to left here. I prefer landing right to left in this airport. Left to right, there's a lot of debris at the end of this runway. If you think the part we're taking off from is bad,
Gear down.
you should see the rest of it. Let's check for gear real quick. Kind of hard to see with how tiny this model is. We don't normally do a gear check, but it's always worth doing. Even with how good my vision is, at 38, I have like 20/20 vision. I still couldn't see those gear. I can see them now, but how far away it was, I could not. Okay, getting her lined up. Let's check our frame rate.
Zero losses.
Okay, so I had no losses this entire flight, so I got really good optimized antenna placement, which is good to see. Okay, just checking where Tony is. So if I do have to scuttle the plane, I don't scuttle it into him. And the canopy already started coming off. That's going to be an issue with using these smaller 4,000 packs because the front of the nose is a two-piece system. You have to plug the nose into the fuselage. There's enough flexing that happens there with the glue that I'm using, the foam tack, that it allows the canopy to come loose. I'm going to say again, my final review of this plane, at least from my initial final review for today, is that this thing is a beast. It is not easy to fly. If you are going into this jet expecting this to be an easy plane to fly, I would highly caution that you adjust your expectations accordingly. You've seen me fly this, and I have years of EDF experience, and I can fly almost anything you give me, but this thing is a beast. It is very unassuming. So here's the canopy. There it goes back in place. But yeah, it's a completely different beast. These wings are so highly loaded that it just does not fly the way you would expect most jets to fly. I'm sure Tony sees all the bugs around my face right now. Good thing I doused my ears. Overall, it does knife edges pretty well. You got to give it full rudder to do that. If you're expecting a knife edge jet, that's a scale jet, you can get this one to do it, as you've seen. You can do even better as I learn how to fly it more. I don't normally fly such highly loaded wings. The roll rate is absolutely insane with Tailerons, the way I've set mine up. I would say if you're not used to that, don't set them up. It wasn't too much effort, but it's also not easy to fly. I like it more, but that's just me. Pitch authority is off the charts good. I mean, this thing slides, like it slides around like this where the nose stays fixed in one position. It's actually pretty good. I like that a lot. But overall, it's so wonky feeling in the sky that honestly, I wouldn't advise this. Don't make this your first jet. Don't make it your second, third, fourth, fifth, sixth, seventh, or eighth. Make this your 10th or minimum jet. If you're still getting used to flying, this thing will kill all your confidence. It almost killed some of mine. I can fly some pretty decent looking stuff, and this thing makes me feel like an amateur again. So those are my thoughts, unfiltered as always. I hope you guys enjoyed the KM model Afterburner. This thing's pretty sweet. The guy that runs the site mentioned to me, I don't want to mention his name on camera unless he wants to be identified. He did mention to me that it's the first batch that we have here always stays on. So in later batches, you'll see me flying later on. It will actually be programmable to stay off. So I'm going to prefer that personally. But overall, for the price point, I think it's like 40 bucks for this unit. You can't beat that price. There's nothing cheaper out there. But it does come with a caveat. It's a little bit on the... Other stuff is made a little bit more robust, is a better way to put it. It doesn't make this bad, it just makes it obviously more of a cheaper option. So if you're gonna go with it, I'd say be aware of that. Just add a couple dabs of CA glue and you're good to go. Be aware too that the wires are a little thinner than usual, so you wanna be very careful when you're moving them in and out so you don't snap them accidentally. It's been John and Tony. We'll see you guys again next time. Cheers.
What's going on, YouTube? By this point, you've already watched the successful Maiden and, well, remaiden of the Freewing F5. It's a handful of a plane. Trust me, it's definitely no beginner's level plane whatsoever. It is a real pain in the butt, but it's fun to fly, and it can be very fast if you want it to be, although I'm not buying that 165 mile an hour claim. I can't. The motor I'm using versus the one that the fellow who talked about it was using, there's no way it's that different. They're only like what is it, like half a pound of thrust difference. There's no way you can accelerate it that much. Maybe I'm missing something, I don't know. But in the meantime, we're gonna pop this on my head and we are going to look into the setup for this. I'm gonna record my screen so you guys can follow along. So starting in 3, 2, 1, now. Okay, yeah, I have to talk into the microphone on this thing. Surprisingly, it does actually have one, which allows me to sync up the footage to the plane and the talk and the video and all that. Let's go ahead and get a battery, get it connected. I'm going to use a 4050C smart pack for this. It's kind of irrelevant just for the sake of powering it up. But for the moment, let's go ahead and get it set up. Take the canopy off. You can see the KM Model RC Afterburner in here. It's a good little system. It does have some quirks that we need to address. I'm already working with the fellow who runs the site. You can see there's quite a rat's nest of wiring in the jet. You can also see that I added a magnet there to try to help and hold it on. I'm gonna recommend first and foremost that you run your antenna placement for this model. You wanna run one down the length of it here, as far into the ceiling of the jet as you can get it, and then one along the front here so that you get away from that rat's nest of wiring as much as you can. I also have a remote receiver up in the front here. Hopefully you can see all this. That's invaluable. I had absolutely no frame losses the entire time I flew. Let's go ahead and get her connected, power it up, go over the quick setup. I have a lot of things on my plate today, including going to see Top Gun 2, so I want to get this done before I leave. Otherwise, I may not get the setup video out on time tomorrow, because I'll be tired tonight, being out for quite a while. Okay, so let's begin with this. You can see currently, let's go into the model setup. We're a throttle cut on so the gear pop out automatically. That's to prevent me from lifting the gear while it's on the ground. All right, so we'll go to aircraft type, proceed. Okay, it goes into kind of a safe mode automatically. I have it preset so it tries to roll itself and hold itself into a stall. Anyway, the setup for this is 2 ailerons, 1 flap with dual elevator and 1 rudder. That's the exact flying, the way you've seen me fly it. Channel assign, I'll show you how that's all set up. The input configuration, channel 7 auxiliary 2 is set to be switch A, so that's the gear channel. It doesn't really matter if it's called gear or not. The only thing that matters is what switch controls what. The receiver port assignment is set up so that the throttle is on the right aileron. The right aileron is throttle, number 1. The second channel is throttle. Had to be done that way because you can't pass the, the avian telemetry and a throttle signal at the same time. So I had to put it on a different channell because I'm using an avian 100 amp ESC in here. This is also the motor from the, the E-Flight 80mm X16, which is an FMS 2100 kV Pro motor. So you can see the rest of this on here. I don't really have to tell you what they all are. You can read it for yourself as you're listening to me talk. And so let's go ahead and get out of this. All right. Now let's go into the basics. So you can see my throws are rather crazy, but that's how I like to fly. I like to have all the throw so I can do things that you can normally not do with other models. So I'm getting a ton of deflection. I'd say about 45 degrees up and about 40 degrees down. Due to the positioning of the servos, I was unable to get them to be symmetrical up and down, and I didn't want to give up the up. So as a result, it does kind of lopsidedly roll a little bit if you do a full roll. You can also turn it off with switch D2, or turn it on if you want. I have full span flaps. Those are interesting. I have crow. I haven't tested that out yet, but I have a feeling it'll work okay. And that's pretty much the majority of the mixing. I would say crow and whatnot would be of limited benefit. You may want to consider setting up a trimmable nose wheel instead. I find that to be more useful generally on a model like this. But that's what I flew with, so that's what we're going to talk about. Let's go into the mixing. We'll go through all this as quick as I can. We'll go to the throttle mixes, which are 5 and 1 in a little bit. We'll have to cover those as soon as I cover the receiver setup. H to AX2, this is the prevent me from pulling my gear up, or like I can't do anything with the gear, as you see. So pretty much what that does is when throttle cut is engaged, switch H, which is the H to AX2, at a rate of negative 125%, an offset of 100%, causes the gear channel to be stuck at 150% at all times if that's engaged. As you see, when I open the throttle, it goes down to 100. When I engage it, it goes to 150. It's a really good mix. It's not for everybody. I like it though. It keeps me from pulling the gear up while I'm on the ground, which can happen and has happened in the past. So it's just kind of a big dumb brain time fix for me. So elevator to flaps, switch B. I tried this out. This was like a high G maneuvering mix. Let's go ahead and engage the gear up. That's what that does. It just kind of dumps the flaps out a little bit to aggressively help with pulling the plane around in a high G maneuver, but the stabs are so powerful they don't really need it. But that's set up as a curved mix, as you can see here. Point 1 is at, what is it? 50%, so negative 50% pulling up, and that's set to 63% with, sorry, point 2 is 63%, point 1 is 74%. And because it's an Expo curve, I didn't have to add anything to the other side to get the flaps to do anything, but the flaps have been set up so they can't move up any further than they currently are, so that's an absolute travel limit, so this mix doesn't do much. I tried out a high alpha mix that you guys have seen me do with other ones. So when I throw switch B, you can see the ailerons pop up in crow as I pull the elevator back. This is what I use in the Viper, but it was of limited use on this jet, so you can see how it's done here by looking at the screen, but ultimately I've already tested it and it didn't work very well, so I'm not going to spend any more time talking about it here unless you guys really want to know more about it. You can see my other set of videos for more on that subject. Let's see here, flap to left aileron, this is what causes crow to work. So if we, actually crow and full span, so position 1 on switch F, negative 47% with an offset of 100% gives you the deflected ailerons. They still move. I could have locked them from moving, but I decided it would be best not to do that. I don't recommend landing like this at all. If you are going to land it though, you might want to try crow. I think that might help it. Crow is position 2 on switch F. 80% rate to to an offset of negative 100%. And that gives you a 1-to-1 movement of the ailerons to the flap, as you see here. If you don't give it the offset, it won't be 1-to-1. That helps introduce washout into the wing so that it's aggressively biting, or it's not as aggressively biting the air in this zone, and it should get the root to stall first before the outside part of the wing. But because the ailerons aren't at the very tip of the wing, you may still have 2 stall zones, which I don't think it's going to be very effective given the size of these ailerons. If I was to come in here and actually cut this wing so that the aileron moved up and down throughout the entire thing, that might actually work really well, but I'm not really prepared to do that right now. Something I might look into in the future. For the Tailerons, because it's on a dual elevator setup, I have aileron mixed to left elevator. I have it dampened, so as you see here, it's not 1-to-1. So as I move the stick a little bit, the ailerons move more than the Tailerons do. Or for the correct parlance, the differential stabilators don't move as far. That's by design. Positions 1 and 5 are full deflection, and then positions 2 and 4 are negative 5%, and that's set to be 10% of the stick. But 10% of the stick, in the way I've used my Expo at like 80%, is like half the stick, so that I don't get a crazy amount of roll rate with the Tailerons active. That's what I prefer. It works really well for me. It's on a curve mix. It's using Expo. Expo meaning it softens the curves instead of it being a linear point to point. If any of this is over your heads, let me know. I can always explain in the comments. That should be all the mixes. It's really not that complicated of a jet, at least compared to some other mixes I've done in the past. Let's go over dual rates in Expo, and then we'll come back to the receiver setup, and then we'll come back to the throttle-based gains, and then we'll wrap it up because it shouldn't take long to do this. I use 85% Expo with 100% rates. Those of you who poo-poo the idea of Expo have not tried flying this plane with no Expo yet. I would not recommend it. 85% Expo at 150% rates, which is what I use. Looks like this, 0 Expo. It just barely moving the stick causes significant over control. So we're not gonna do that. Although that looks a little weird. Something got messed up in the system here. There we go. Now it's working correctly. For pitch, I'm using 85% Expo as well. So I have to be halfway through the stick to get what normally people would get with just a little bit of, or like somebody's full deflection on this model would generally be like right here, and mine is here, as you can see. And what that gives me is the ability to fine tune how much throw I'm getting, especially with these servos in the back, the AGF RC B13 DLMs, which are very precise. So that kind of precision, you need the Expo to dial them down, otherwise you'll over control the model. And this is a very easy model to stall. Very, very easy. Rudder with jets, I almost always stick with 85% Expo to prevent me from over controlling it. It's very easy to basically stall the vertical stabilizer in a knife edge pass if you give it too much rudder input at speed, without enough speed even. So that's my my rate setup. I can show you the servo setup while we talk here. Again, it's 150% rates for everything that can support 150% rates. I can't do that on the stabilators because if I go to 150% on those, they will bind by hitting the foam. As you can see there, it's kind of a tight fit, so anything further than that is too far, but I can get 150 moving back pulling it, so that works for that. The rudder is 123. I can't go any farther than that. It'll bind on the vertical stabilizer. The ailerons are 150 and 150, and the gear is currently locked to 150, but it moves to 100 and 100. That's the majority of it, so let's get into the gains. And you can see in the screen I've got something called pitch, yaw gain, and roll gain. I'm able to name my channels on the IX20. So let's go in and show why that's necessary, but to do that we need to get into forward programming. So go to gyro settings, AS3X settings, and you'll see my gain sensitivity is 1x. Gain values of roll are 80%, 90% pitch, and 85% yaw. Heading. With the heading mode, which is not really a heading mode, it's just legacy, that's what I call it. It just means more stabilization. Roll is 90%, pitch is 100%, and yaw is 95%. And then in safe, that's all the default safe values. I have the Taileron set up to turn off in safe, so I can't over control it, because the Tailerons wouldn't be limited. I'd have to like make a new mix for them to limit them. It's just easier to do it this way, where you turn off the mix for the Tailerons when you go into switch for the safe. Of course, it disconnect it. You have to be like a certain distance from some of this stuff from these receivers for it to not disconnect itself. So you can see I've got throttle-based gains as I throttle up with my, they're all based on throttle and flap position. So when my flaps are out, I get more, and when my flaps are up, I get less. So currently a 50 roll, and as I throttle up, we get less. I need to reduce this and tune it a little bit more, but for now this has worked pretty well. I need to tune it so that there's less roll stabilization at lower speeds. But as I throttle up, it works less, and as I pull it back, it works a little bit more. Let's go to landing, takeoff configuration. So if I go into, what is it, like about landing thrust here, get about 60 roll instead of 47. See how that works? And then when I'm in full landing configuration, I get 73 roll, 80 pitch, and 77 yaw to stabilize the plane. And as I throttle out of it, it goes away. But then when I go to full throttle, like say I'm trying to get out of something and maybe there's some crazy wind shear, I've got the extra little bit of stabilization at the end of the curve to make it work. So let's go ahead and show you what that looks like. If you've seen any of my other videos, you know what's coming up next. We'll just show you one of them because they're basically the same. This is for the pitch and yaw. Okay, so this is the normal flight profile. This didn't need to be adjusted at all, but we will adjust the ailerons in a second. Start it with a position 1 of 14%, position 2 of 1%, meaning halfway through the stick, and position 3 at full throttle at negative 13%. With the flaps deployed at landing thrust at about 50% throttle, it's 39%. At halfway through the range, it's 1%, and at full throttle, it's negative 13. And at full thrust, we are at, full landing config, we are at negative 50 landing throttle, roughly. If I was to fly with throttle, I actually landed it without, but if I did have throttle at this position, it would have been at 82%, 1% halfway, and negative 13% all the way. That helps stabilize the jet throughout the flight envelope. And then if we go to the ailerons, I'm going to make a quick change here. Now that I remember to do it, I'm going to change the aileron stabilization, change position 1 down to 10%, and then we'll have halfway through the stick be 8%. It's not a huge difference, but I just want to make sure that it's stable throughout the flight envelope. So I want to have very, very little change in how this works. And I'll show you how this looks when we're in different configurations, and then we'll wrap it up. So let's go ahead and throttle up real quick. Okay, now we're throttled up. So at half thrust, this is what the ailerons look like when they're stabilizing. It seems like a lot, but it's really not. It's enough. Elevators move a little bit too, stabilators rather, and the rudder moves a bit as well, which also makes the nose wheel move because it's all tied together. Now when we're in landing, takeoff configuration for like landing, if I have to land with half flaps for any reason, like say the CG is a little wonky, this is how much the ailerons stabilize. And if we go to full landing flaps, we have that much movement, and the stabilators correct this much, and the rudder corrects that much. So you can kind of hear how much it's moving. It sounds excessive, but it's really not, because you're going to be flying at a lower airspeed at that point. So you'll need that stabilization that you wouldn't have if you just had everything be flat across the board, which is why we use on this channel those gains the way they're set up. Throttle-based gains work exceptionally well for jets. I don't see a reason to stop using them, basically. Do they need to be tuned? Absolutely. But are they inherently bad? No. And this jet really needs a gyro. All right, guys, that's pretty much covered everything. If there's something I didn't cover, I want you guys to let me know. I can always answer in the questions in the comments. But I just wanted to make this a quick setup video, because going through and making an hour video for all this stuff is a little excessive, I would say. So I really appreciate you guys watching. Let me know what you want to see in the future, and happy flying. See you guys next time. Cheers.